In this lesson, we're going to look at geometric sequences. Previously, we looked at arithmetic sequences where there was a common difference. In other words, the sequence went up by the same amount each time. In a geometric sequence, instead of having a common difference, we have a common ratio. It's going to be multiplied. Each term is multiplied or divided by the same amount each time. So the common ratio is represented by the letter R, where the common difference that we saw for arithmetic was represented by the letter D. The first term is still represented by the letter A, and so this leads us to the formula to determine the general term of any geometric sequence as T sub n is equal to A, the first term, times the common ratio to the exponent n minus 1. So it should look familiar, this formula. It should sort of look like an exponential function. And is, if we just switch the letters and a little bit, then we've got ourselves an exponential function. R is our base. So it's what we're growing by or decreasing by from one term to the next in the sequence. If R is greater than 1, then the terms are going to increase. And if R is between 0 and 1, the terms are going to decrease. So we're familiar with that as well from exponential functions. Therefore, if a sequence divides by 2, in other words, if each term is half as big as the term before it, then R would have to be 0.5. If each term was 3 times as big as the term before it, then R would be 3. So where does the formula come from? Well, again, if we think about a sequence, if our first term is A, and then our second term is going to be R times that, so A times R. And then our third term is going to be R times the term before it, so AR times R. And then the next term would be AR times R times R. We're going to multiply each term by R. It's going to get R times bigger. Well, obviously A is A and A times R is still AR, but we can simplify A times R as AR squared. And A times R times R times R is AR cubed, and so on. What it turns out is whatever n is, there's always one less R in the formula, or in the term, than whatever n is. So in the first term, there's no R's. In the second term, there's 1 R. In the third term, there's 2 R's. So it's always going to be n minus 1 R's multiplied together, so we write that as R to the n minus 1. And again, that's where this formula comes from. So find the general term for this sequence. So it's not, we need to look at, anytime we have a sequence, does it have a common difference or common ratio? So looking at this one, I can see that it's going multiplied by 3 each time. 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 108. So not a common difference, a common ratio of times 3. First term is still our A value, which is 4. And so the general term would be T sub n equals 4 times 3 to the n minus 1. And again, this is the general term for this particular sequence. So I could find out any term in the sequence. If I wanted to find the 50th term, I'd just put 50 in for n. I'd do 4 times 3 to the exponent, 49. That would be a very big number, by the way. Because like geometric sequences, like exponential functions, are going to grow very quickly. Is this sequence here geometric? Well, times 2 times 2 times 2, yes. There is a common ratio. If there's a common ratio, that makes it geometric. Here's a nice little one to think about. You get paid $1 on your first birthday, and it doubles each year after that. How much will you get on your 20th birthday? So in other words, you get paid $1 on your first birthday, and $2 on your second birthday, and $4 on your third birthday. Let's write the sequence out. 1, 2, 4, 8. How much money are they going to give you on your 20th birthday? Well, It's going up by 2 each time. That's the ratio, doubling. So r equals 2. Our first term is 1. T sub n is going to be 1 times 2 to the n minus 1. So on our 20th birthday, that means n equals 20. So t sub 20 equals 1 times 2 to the 20 minus 1, which is just 19, of course. So 2 to the 19. Nice. $524,288. That would be a nice birthday present. But not as good as your 21st birthday, in which case you would get over $1 million, almost $1,050,000, or your 22nd, where you'd get over $2 million. You get the idea. And that's it for this lesson.